Hello everyone, good evening. Just write your name in the chat box. Okay, so in the last class, we have discussed about polymorphism, right? Today, we are going to understand the next principle. It is all about inheritance. So first of all, what is polymorphism? It is a process where multiple times multiple purpose. Be on mute. Okay, so let's see. Understand the concept, everybody. So yesterday we have seen like what is the polymorphism and how many different types are there. Then out of that, one type, that is compile time polymorphism, we have completed yesterday. I also asked you to do an assignment. Have you completed that? What is the status? Yes or no?
Yes, ma'am, I tried.
Okay. So today, as I told you, to do runtime polymorphism, you just need to understand the concept of how we can relate two different classes together, how we can reuse, the methods and whatever the content you are writing in that particular class in other classes. That part we need to understand the relation, how we can maintain the relation. So what is basically inheritance? Inheritance, it is a process where you can simple acquire properties of one class into another class. So in polymorphism, we have already covered method overloading concept. In inheritance, I will be covering method overriding concept. But before that, let's understand what is exactly inheritance. So guys, it is a very simple topic and it is most important topic I can say. Why? Because complete Java programming, it is based on inheritance principle only. In Java also, you will get this relation. What type of relation? It is all about parent and child relation. Okay. So every parent, they can access their owner properties only, and the child can access everything from parent as well as child property. Correct? So basically, how we can implement this relation in programming? So we have this beautiful, I can say, principle that is called inheritance. So what is inheritance? Acquiring properties of one class into another class, that is called inheritance. So how it is possible? Just observe, everybody. Suppose I'm designing here one class, okay? Class A. And in class A, I'm having one method. Consider I'm having M1 method, okay? Now there is a one more class, class B. And class B also having one more method, let's say M2 method. Suppose, if I ask you, when you create object of a class A, how many method you guys are able to access? When you create object of class A, how many method you guys are able to access? Both classes, whatever I have designed, both are what? Independent classes, right? Currently, there is no relation. So obviously, if you create object of class A, how many method you can access?
Only one, ma'am.
Only one.
That is M1.
Only M1 method we can access, correct? If I create an object of class B, again I can call only one method.
One method.
Right, M2 method only. What is happening internally, in Java, there is a super class available. And that super class is called object class. Okay. So whatever class you design, that can be A, that can be B, anything, any predefined class or any kind of, I will say, user defined class, everything will be the child of user defined class. Everything will be the child of this object class. Remember. So when you design any class, you will able to see in this way structure, object, and then object who is a child of object class. A class is a child of object class. Here what the structure will be? Again same, object, and who is a child of object class? Then here B is a child of object class. And that is the reason when you design any class and if you create any object, at that time, you guys are able to call method from that class as well as method from object class also. Let me show you this point. See, you can take any example. Example, I will be taking this Amazon page, right? Yesterday example only. So if I'm taking this Amazon page and I'm just creating, I have just already created that P1 object, right? So once you write now P1 dot, can you see what is coming here? Can you see few methods? Whatever search method we have designed in that page, that method you guys are able to call. But along with that, can you see these object methods are also you are able to call? See, those methods are coming from object class. Those methods also you guys are able to call, right? Yes or no? So why it is possible? Because of object is a parent class in Java. Got the concept? And that is the reason when you create a object for any particular class, those specific or independent method you can call, along with you guys are able to call few methods which are coming from object class. So object class is a super class in Java. It is a parent class in Java. Remember the point. Is this clear? Yes.
Yes, ma'am.
Now let's see. So the concept is what? Now consider I'm having two different classes. Okay. One more time, class A, and which contain M1 method. And there is a one more class B, which is having M2 method. Consider my class B wants to access method from class A. Okay, so every time what is the solution? You need to create an object and then only you can access everything from that class. But here, now I'm going to apply this inheritance concept. What is inheritance says that if you want to acquire properties of another class, you can directly provide a relation between two different classes. So that means I can make a relation between A and B. So what relation and how we can maintain that? So you guys are going to use one special keyword, okay, to provide a relation that is called extends. You guys just need to write class B extends what? Class A. So what is this? What will happen once you write extends? See, whenever you write extends, guys, extends, whatever you are extending, that is your parent, remember. So here the hierarchy will be like this. A will become a parent class and B will become a child class. Remember, here A is a parent class and B will become child class. Same term, you can refer with one more word. A will be simple, you can refer as a super class, and B, you can refer as a subclass. Similarly, you can refer, A as also base class, and here you can just refer B as a derived class. Remember this logic, okay? And what is the rule? See, whenever any class is a parent, super or base class, parent can access only parent properties. That is the first rule that you need to understand. Second, what child can access? Child can access everything from parent as well as child property. So this time, by following the same rule, if I ask you, if I create object of this A class, how many methods this time I can access? One or two?
One.
Only one. Very good. Only one, guys. Because parent, what is the parent rule? Parent can access only parent property. What about child? If I create object of B, how many method I can access?
Two. A and B.
This
Two
time,
methods.
exactly. This time we can access M1 plus M2. Both method we can access. So this is possible because of what? Because of this beautiful relation. This is nothing but your parent and child relation. And that is the reason child can access everything from the parent as well as its own property. Are you understanding? This is the concept that we can achieve. Basically, this relation we can achieve in the inheritance. But see, what the content or what the topics we are going to learn, let me explain. First, this is the relation. Now I'm going to cover, some types. How many types are available in inheritance? Basically, there are 5 types. Okay. First, it is all about single level. What is single level inheritance? Everybody focus. If I design in this way, I have a class A who is a parent and class B, which is a child class. So this is a parent class and this is a child class. In this relation, obviously one more time, if A class having M1 method, if B class having M2 method, right? So how many method A class can access this time? A can access only M1, but B can access this time M1 plus M2. Both method we can access. So whenever this relation will be there, this relation we can call single level inheritance. Okay. Whenever there is a relation in between two different classes, that relation we can simply define as a single level inheritance. Second type that you guys are going to understand, that is called multi-level. See, there is a possibility, there is a possibility that one parent, okay, and there is a one child, suppose, and again this child can be the parent for another child. If this relation you are having, this is called multiple or multi-level inheritance, not multiple, okay, multi-level inheritance, because see, the number of classes get increased and the number of levels we can increase. That is the reason it is called multi-level. But now again question remains same. What will happen this time? See, M1, suppose A contains M1 method, B contains M2 method, be on mute, and C class having suppose M3 method. Done. This time if I create object of A, how many method I can access again?
Only one.
As a
One.
parent can access only its own property. So again understand the logic, only one method. If I create object of B, how many method I can access?
Two methods.
Two. M1 plus M2. Both method we can access. What about C? C is a child for B. So I can say the immediate parent of C is nothing but B class. And A will be considered as a grandparent for this C class. So this time if I create an object of C, how many method we can call?
Three.
Exactly. This time we can call M1, M2 and M3. So are you understanding the relation logic? Correct. Now the third type, which is very interesting. It is all about hierarchical inheritance. Okay. What is this hierarchical inheritance? It says that one parent may have multiple child. Let's say this is again B class, and here there is a one more relation that is called C class. One parent may have multiple child. So here again same logic. M1, it is like A class having M1, B is having M2 and C is having M3. But if I ask you again the same question, how many methods you can call with the A? Answer remains same, only one method. Here how many method we can call?
Two.
M1 plus M2. And what about C?
Two
C is the child of A. Exactly. So here we can call only two, M1 plus M3. Can we call M2 method also using C? No.
No.
See, the relation is available here. B relation with A, C relation with A. But there is no such a relation between B and C. Remember. So one parent may have two different child, and that is called hierarchical inheritance. Now let me tell you, in Java, we can implement, these three inheritance automatically. I mean, there is no such a restriction, nothing. Okay, we can directly implement these three relations. But there are two popular relations that we can't implement directly. We cannot achieve that directly. For, to achieve that particular inheritance type, you need to understand what is interface. So the fourth type in this inheritance journey, that is called all about, I will say, fourth type is all about multiple inheritance. What is multiple inheritance? And there is a fifth type also available, which is called hybrid. See, what is hybrid and multiple inheritance? Basically, this you can't achieve directly in Java. Let me tell you the relation. What is happening in multiple? Multiple says that there is a possibility that two parent, maybe one class is trying to acquire properties from two different parents. That means two parents having one child. This is invalid scenario. Okay. One child can have only one parent, But suppose any class or any child class want to access, properties from both different classes. In that case, this scenario is invalid in the inheritance journey. And that is the reason in Java difference, like in C++, we can achieve all the type, but in Java, we can't achieve multiple inheritance directly. But yes, there is a solution. It doesn't mean that we can't follow. No, we can follow, but with the help of what? Interface concept. Remember, so these three we can directly implement. There is no problem at all. But to understand multiple inheritance, you need to wait for some time. I will be covering interface topic. In that, this topic you will understand. So at a time, from two different parents, if any child class want to access the properties, it is not valid in Java. What about hybrid? Hybrid, it is actually combination of this both, hierarchical and multiple inheritance. Means what? See, you will get this kind of design. Let me design with a different color. See, suppose there is a one parent, okay? One parent obviously having two different child. So this is valid. Okay, let's say B, let's say C. But again, from B and C, someone else want to acquire the properties. This is called, the combination of hierarchical and multiple inheritance. So the name is hybrid. Got the concept? So how many different types of available, like for inheritance available? I will say there are 5 types available. Out of 5 types, 3 types, single level, multi-level, hierarchical, you can directly implement. But multiple inheritance and hybrid, it is not directly supported in Java. We can implement that using interface. This is the concept you need to understand. Now, if you want to understand again the relationship in a proper way, you need to understand 4 important scenarios in inheritance. Okay, that will explains everything. Example, see. Again, I'm designing my classes. Let's say class A, and class A having M1 method. Again, I'm designing class B. Everybody just focus. And class B having M2 method. But once I write B extends class A. So here B will become child, A will become parent, right? Now to understand complete relation, these 4 scenarios are important. So please focus properly. First scenario, if I create, child class reference and child class object. So you just need to understand how exactly, how many method we can call with this particular scenario. First point, how you can design this statement. How should write, like how I should write, guys? Child class reference and child class object. Tell me how we can write this. What is a child class? In this particular example, B is a child class. So how you guys are going to write the statement? See, you need to write in this way, right? B, then any reference variable. So this left-hand side part will be always reference part. Remember, is equal to new. And then you are going to create B object. What this statement means? Child class reference and child class object. Using new keyword, you guys are able to create an object in the JVM, right? So B is nothing but constructor here, child class object, right? Because of constructor, object will always initialize. So child class reference, child class object means what? This is the statement that I have designed. So using P1, again, using this scenario, how many method we can access? See, from the P1, I can access M1 method. Along with that, I can access P1.M2 method. So can I say that parent and child method we can access with this scenario? Yes or no?
Yes.
It's the first scenario. And with this scenario, we can access properties from parent as well as from child. Now there is a second scenario that you need to understand. If I design parent class reference and parent class object. So first convert this. How we can convert? How we can write this statement? So parent class is nothing but A class. A, any reference variable is equal to new and again constructor of A. Because I'm going to create an object of parent. So here I can say A is a parent. correct? So with this scenario, how many method you can call? A1 can call only one method, correct? So can I say that with this scenario, you can access only parent method. This is a second scenario which is valid. Now let me design third scenario. Everybody focus. Third scenario says that if I create parent class reference and child class object, how many method we can call? First, let's design. See, parent class, that means A reference I will be writing now A2 is equal to child class object. That means what to write? New. And किसका object create करना है? Tell me. Where is the child? B. You have to create an object of B. So now tell me, with this scenario, how many method you guys can access?
2.
Okay.
1.
See, the rule never change. Parent can access only parent properties only. Remember, reference always matter, guys. Whatever class and whatever reference you are providing for a particular class, that reference always matter. So here, if you are passing A, that means parent reference, you guys can call only and only one method from the parent. Remember, even though you are creating a child class object, but reference is available for a parent. So parent can access only parent properties. Are you getting this point? Yes or no? Now, there is a fourth number scenario. Yes, correct. The fourth number scenario is what? I can say, if I design in this way, child class reference and I will say parent class object. Let's design this. Suppose I'm writing my child class, that is B. B2 is equal to new, and I'm writing object of parent. What will happen in at this time? Tell me. How many methods you can access?
2 method.
हर एक रेफरेंस में हम लोग सब कुछ कॉल कर सकते हैं, राइट? नो गाइस, बेसिकली this particular scenario in inheritance, it is invalid scenario. Now tell me, with the reference of child, can you create object of parent? See,
No.
parent in a real time, what happens, you know, parent can hold their child, but child can hold their parent. What do you think? No, no.
No.
We generally don't follow like this kind of I can say the concept, right? Parent always hold the child, but child cannot hold any parent, and that is the reason if you design this scenario in the code, you will get error here. It will ask you that you can't create an object of parent with the reference of child. So what you can do, you can, if you want, you can just convert parent into child, and then you can, that means typecasting you can do. But what is the purpose of that, you know? Because we already have a separate scenario for child, where we can create child class reference, child class object, and we can call everything from child and parent, right? So this scenario, it is completely invalid in inheritance. So how many scenarios are valid? If you want to access any properties from the child or from the parent, I can say only 3 scenarios are valid in inheritance. Got the concept? Now, whatever I have designed here, let me explain it. Okay, so just focus, everybody. See the practical point. So yesterday we have completed polymorphism, method overloading. Today, let me start with inheritance. So let me again create a separate package for inheritance. Just focus. I'm designing com, again OOP dot. Here I'm writing what? Inheritance. Done. And here I'm creating one class. So let me first design a simple class. Example, I'm writing here what? Let's say inheritance demo, and just follow everybody. This is my main class, inheritance demo. Here I'm just writing the same example. Suppose I have designed class A, which contains what? M1 method. So let me just design M1 method. Everybody focus. And here I'm just writing what? A simple message. M1 is calling, let's say, done. And then I want to design one more, let's see, class B. And in class B also, I'm having, let's say, one more method, that is M2. And I'm writing a simple message, M2 is calling. Done. So currently, if you observe, both classes are independent, right? Yes, we can design a cloud code in this way also. In one class, there should be only one public class available, guys, and other classes, if you want to maintain, just write without any modifier. That means default pattern. Okay. Now you can just observe here. I have designed two different classes. Currently, both are independent. So if you create object of A, you will get M1. If you create object of B, you will get M2, right? But if I'm writing this relation, say it is extends what? Class A. Here, A will become parent, right? A is a parent. And B is what? B is a child, remember. And this is a what type of inheritance? So I will say it is a single level inheritance. Everybody focus. So now both classes are in relation. Let's understand now the scenario part. So this is my main class which have main method. Now I'm going to show you all these four scenarios here. So just focus. Example, I'm writing here first, scenario number 1. Okay, just focus. If I design child class reference and I will say child class object. So let's see what the answer we will see or we will get, right? So how to design child class reference? So here the B is a child class. B1 is equal to B, again constructor, right? Using new object will create and B constructor will initialize the object. Now see the logic. As per this scenario, if you create child class reference, child class object, you guys are able to access everything from parent as well as child. That means if I write P1 dot, what I can access? Can you see? I can access M1 method along with M2 method. And please focus here. M1, what is the return type of this method? It is a void. Hai na? And where, from which class it is coming? It is coming from class A. Try to read this. Try to understand this. Okay. M2 method is coming from class B. Correct. Now, if I write here M1, obviously I can call M1 and M2 also. If you run this code, you will get only two messages. Right? M1 is calling, M2 is calling. Got the concept, everybody? The first scenario is working fine. With the child class reference, child class object, we guys are able to call everything from child as well as parent. This is the first answer, right? First scenario. Now let me come to here and let me write scenario number 2. So what is scenario number 2? Just focus. Scenario number 2 says that if you design parent class reference and parent class object, what will happen? Here we can call everything from parent. Example A, A1 is equal to new, again constructor. What you can call? A1 dot, I can call everything only from parent. Can you see what we can call here? See only M1 method and rest of the method coming from the object. Yes or no? So we can access only one method which is coming from parent. Got the concept, everybody? If you run the same code, you will be able to see this result. M1 is calling. Yes, is this clear? The point is clear. What is scenario number 1, scenario number 2? Let's design now scenario number 3. Everybody focus. Let me remove this console now. Let's see. Now scenario number 3. What is scenario number 3 says? See, if you design parent class reference, be on mute, and child class object. Okay, what will happen this time? See, we are able to design, there is no problem at all, and the reference always matter, right? And that is the reason everything you can call from the parent only. So how to design this first? Let's understand. You have to create a reference of parent, that means A2, like any reference variable you can follow. is equal to new and the object of child. So you have to write here B constructor. This time, as per a rule, we can access every method from the parent. So if you just say A2 dot, see the method. Only one method you can access, that is M1 method, which is coming from the parent. And see the parent class name is also available. So I can access M1 and this time if I run the code, again I will able to see the same result. First, both method, second time only one method. In third scenario, again only one method. What about the last scenario? As I told you, the last scenario is completely invalid. Scenario number 4. If you design child class reference and I will say parent class object. So in the real time also, child cannot hold any parent and that is the reason it is invalid scenario. But let me show you. If I design in this way, see my child class is B, let's say B2 is equal to new. And if I'm writing, constructor of parent, see what is happening. In Java, like Java also says that type mismatch, you cannot convert from A to B. That means from B reference, you cannot create this A object. So A object I cannot convert into B. If you want to convert, you can follow the type casting. See, either you can cast to B or you can just change the type of B2 to A. But we don't need to follow this because we have a ready-made scenario for that. So this scenario, if you try, you will get an error. And that is the reason in inheritance, only these 3 scenarios are valid. So the point is clear. If you want to understand how we can acquire properties from one class into another class, extend is a keyword that you can follow, okay, to provide a relation. So this is only one type I have achieved. Now let me show you the rest of the type. See, what if tomorrow there is a one more class, C, class C, and this class also containing one method, let's say M3. Same example, whatever I have explained now, same example, just focus. This is my class C and which is having M3 method. And suppose I'm writing here, okay, let's say M3 is calling. Then this time it is independent. But if I write, okay, fine, C also wants to access the properties from other class. Example, extends, let's say B class. This time, what will happen? Here, the B, which is already child of A, will become parent. So can I say B is a parent and C is a child? Everybody, clear now? This is a relation. But if you focus the hierarchy, we have already A class, which is available. See, already we have designed A and now there is a B is a child of A. And again, I'm designing this class. So what type of inheritance it is? It is a multi-level. Yes, very good. It is a multi-level inheritance. This is the point that you need to remember. Be on mute. So this is a multi-level inheritance and rule again same, na? So let's apply all 4 scenarios here again. So this time I'm just commenting this part, okay? Because this time my child class is different. C will be the child class. So if you design C, let's say C1 is equal to new and the object of also C. The child class reference, child class object, you can call everything from parent, that means from grandparent also and from child also. So can I say this time, if you just type C1 dot, can you see this beauty? You guys are able to access M1, which is coming from A, M2, which is coming from B, and M3, which is coming from C class. So all 3 methods, we guys are able to access. Let me call M2. Now let me call C1 dot M3. And just for a time being, let me just comment this part because now parent is also different. Right. Let me just comment this part and see the result. If I execute this, then this will be the result. M1 is calling, M2 is calling, M3 is calling. Right? Now, what about this? For C class, we have an immediate parent and that is what? B. That is what? B class. So if I design parent class reference, that means this time I have to design B. Let's say B1, new. Again, I'm creating object of B. So now tell me, how many method B class can access this time? 2, right? Why? Because B is a child of A class also. So B can access everything from A class also. So if you write B1 dot C, again you can access M1 and M2, both a method from B class. And that is the reason here, one more time, I can write M1, I can call M1 method along with this M2 method also. That's it. And if you run this code, obviously you will able to see the result. And this is called inheritance, guys. Now let's see third valid scenario for C class. So child class reference or parent class reference and child class object. Child class reference, parent class object is invalid. So let me design this third valid scenario. Parent is B. So I'm just designing B, let's say B2, right? Is equal to new. And I'm just designing object of a child class. Here, again, reference will matter. And that is the reason, B1 or B2 dot, you guys are able to access everything only from the parent. So again, you are getting the same result. You can call M1. Using B2, we can call M2. And hence, if you run the code, you'll be able to see the result. Got this concept, everybody? So what type of inheritance it is? Multi-level. And what about hierarchical? See, third type of inheritance. What the hierarchical says that one class may have multiple child. This is a possible. Like currently we have B class, which is already a child of A, and C class is here, right? Child of B. But can I design one more class which will be the child of A? Yes, we can design. So let's see. Here, consider, I'm just writing here one more class. Let's say class, just a minute, class D class. Okay. And again, D also containing one method. Now, I will be not writing the full code, just focus. Suppose I'm just going to print something here like M4 is calling, right? And this time, what I have to do, if I want to become like, if I want to set this D as a child for A, what I have to do here? You guys tell me. I want to set up this D class should be the child for A. That means what I have to write next?
Extend.
Extend A.
Is what? A, correct. So this time what will happen? A is a parent here, correct? A is a parent for child D. Very simple, correct? A is a parent for child D, and this time A is a parent for D as well as B. So it is called hierarchical. Everybody clear? It is called hierarchical inheritance. Are you getting this concept? Are you understanding, everybody? This is actually called hierarchical. But if I ask you, chalo, in hierarchical, let's say, okay, in hierarchical, now tell me, M, like here we have M1, here we have M2, right? And here we have M3. Or yeah, we have design M49 right now, okay? So now tell me the relation. There is no relation in between B and D, right? Because B is a direct child for A class and D is a direct child for A class. So this time, if I design child class reference, that is D class reference and D class object, how many method I can access?
2, 1.
Only 2?
2.
1 plus M4, right? So can you guys complete this code now? Just create a 4th number class and just design all the rule. Yes or no? Design all the scenarios. Yes or no? Are you understanding, everybody? You just need to create a new class and you can design this part. Okay. All these 4 scenarios try. So you guys are already aware of the concept now. If you design parent class reference, child class object, the parent method. Parent class reference, parent class object, again, parent method. And if you design child class reference, child class object, both method. So just complete this code now. Okay. I hope this point is clear to everybody. Yes or no?
Yeah.
Any difficulty, any doubt till this? Yes or no? Any difficulty, any doubt? Concept is clear? Let
Yes,
me
ma'am.
write a proper. Okay, hierarchical inheritance. Anything else? So the main concept is these three types you need to understand, because these three are valid, in Java. We can directly implement. There is no problem at all. So let me now explain to you a real-time scenario. Now consider, guys, what I'm going to do is, or let's do one thing. See, I'm going to design one car class. Okay, let's see very simple concept. So every car, okay, every car having a certain feature, like same feature. Example, car can start, right? Car can stop, and every car required what? A refuel, right? So suppose these three methods I'm going to design in the car class. Now tell me, what can be the object of car class? See, if I design any other class, let's say BMW. So BMW can become a object of car class? Yes or no? Possible? Car is a class. So kya BMW, it is one of the object of car class? Yes or no?
Yes, ma'am. Yes,
Can
yes,
I design, can I design truck as an object for car? No, na?
yes. Yes.
Here, no. What is the relation? No, we can't design. Why? Because truck is not object of car. Every truck is a car.
No.
Every
No.
truck is a car. No. But every BMW is a car. Got it? Obviously, every car is not BMW. Hai na? The relation. You just need to understand the relation. So let me take this example. See, what I'm going to do is, I'm going to design one class. Consider car is my parent class, and here BMW is a child class. The child class can contain its own method. Example, I'm going to design here auto parking, auto parking method. So if you just focus now, just focus. This time I'm going to create a separate class. Let's say my class name is a car itself. And in the car class, I'm just going to design three methods. So everybody focus, public void, and let's say start. Okay. And inside a start method, I'm just writing a message. Okay, fine. Car can start. Very simple. Okay, this is a method coming from car class. Now let me design one more. Public void what? Let's say refuel. Okay, done. And here I'm going to write a message. Fine. Car and car can refuel. We can refuel a car, obviously. Then third, I'm going to design one more, that is a stop method. And here I'm just writing a simple logic. Car can stop. Done. Okay. Now I'm designing one more class. So just observe, I'm designing one more class. This is BMW. Let me take a BMW class. Okay. In BMW class, let's say I just want to define a relation that BMW extends, features from car class. So what this time, happen exactly? From the car, all three method BMW can access now. Yes or no as a child.
Yes.
Yes.
And BMW may have its own method. So let me design one more. See, public, I will be writing public void auto parking. Let's see, everybody. Auto parking. This time, let me write here a simple message. And I'm just writing, okay, let me take a camel case format, auto parking, okay. And then I'm just writing, okay, this is a method coming from BMW. It is a BMW, auto parking method. That's it. Okay, done. I'm designing one more class where I'm going to write a test case. This is just a relation. Now I just want to test the car. So let's test the car. Here I'm going to take main method and see this beauty now. So car is a different class, BMW is different class, and test car, it is a different class. Remember. Now I'm just going to write a scenario once again. What if I design child class reference and child class object? What will happen? What is a child class this time? BMW. BMW B1 is equal to new BMW. What will happen this time? Tell me. We guys are able to access everything from BMW as well as car? Yes. So can I write now? B1 dot what? First, I'm saying that, okay, fine, start. Okay. So BMW start hua. Let's see. BMW dot what? B1 dot what? I'm just doing what? Let's say I'm just doing this part, refuel. Done. And then B1 dot, I'm just calling this method, auto parking. And then I'm calling what? Stop method. Okay, stop. Let me call stop. Done. This time, if you focus, what is this start, refuel, and stop method? I will say this is a inherited method. Remember, कौन सा method inherited है? Though the method which you are calling from the parent, that is your inherited method. So can I say that refuel is also inherited? Yes. Stop is also inherited. But क्या auto parking inherited है? No. This is what I will say individual method. Remember, this is your individual method. Clear? So these three are inherited method, but this is your individual method of BMW class. Obviously, this time if you run the code, you will able to see that first car has start, car has refuel, and then BMW auto parking has simple called, and then car stop. Are you understanding? So what relation I have implemented here? What is this relation? One parent, one child. What is the relation?
Single level.
Single level inheritance. Correct. This is a single level inheritance. What if I want to design one more? Let's say I'm going to write here one more class. Let's say Audi. Everybody focus. Audi class. Okay. Okay. Don't require main method. And I'm just writing here. Okay, fine. This also extends feature from car. What will happen? What is this relation this time? Now car is getting extended by two different child classes. So what relation it is? It is a
Multi-level.
again hierarchical relation. How come multi-level? Right? It is a hierarchical, no? One class may have two different child. So this time car is having two different child, right? And suppose Audi can access everything from car this time, but Audi can't access everything from BMW. Okay, and suppose Audi is having its own method. Example, I'm writing here one method. Example, what method we can take? Okay, fine. Auto engine, some method. Okay, I'm just writing randomly. Let me just write auto engine. Yeah. Just focus. So this is a method which is coming from Audi. Done. I'm writing here auto engine. Just focus, everybody. Done. So what will happen this time if I go to the test car again, and if I just create this kind of scenario again, like Audi, right? A1 is equal to new, again Audi. This time what will happen? We guys are able to access everything from car as well as Audi. So using A1, again all methods you can access. See, start, again A1 dot suppose refuel, A1 dot let's say stop, and again A1 dot auto engine I can call. So tell me which method is independent or individual method here?
Auto engine independent.
Correct. Auto engine is a independent or I can say individual method. And rest are nothing but what? Again, inherited method. Remember the point, everybody. Correct? These are inherited method. So this is only one scenario I have designed. What if you design this one, car C1 is equal to new, and again suppose car. Now tell me how many method you guys can access?
3.
Only parent class method, right? So car here, what is the scenario? Parent class reference, parent class object. Using C1, again we can call only these three methods like C1 start, C1 refuel, and
Stop.
C1 can stop. Right? Okay, not two string, just a minute. Let me write stop. Done. So here, all these are again individual method for car class. So when you run this code, again you are getting all the result like this. Let me just make some separation here so that you will understand, So let me just design this separation. Right. So this time, this is the logic. So are you understand what is multi-level? What is, okay, multi-level we haven't taken. Let me cover that also quickly. So I'm taking one separate class, consider vehicle, right? And in vehicle, suppose I'm writing, okay, one method, let's say vehicle says that every car should have some common things like let's say public, void, and let's say brake. Let's take a very common method, brake. There should be brake available in the car. And okay, brake, it is a keyword in Java, right? So we can't directly write it. So let me write brake feature, something like this. Yeah. And now here I can take this, right? So I'm just writing what? This is a method coming from vehicle class. Remember, this is coming from vehicle class, and this is what? This is a brake feature. Let me write a name. Okay. But this time, everybody focus. If I design here, that car is extending, extends everything. Okay, one more time, extends. Something is wrong. Wait. Extends everything from vehicle. What will happen this time? Can I say, like, I have designed what scenario? Please focus, everybody. Here is the vehicle class. Now all the feature from vehicle is extending by whom? Car. All the feature car extending by whom? BMW and Audi. So this relation
Yes,
is a single
vehicle is
level. This relation is a hierarchical. These three relation is nothing but hierarchical. But if you consider this whole relation, it is multi-level. Correct? So obviously what will happen this time, if you go to the test class, you guys can access everything from parent and the grandparent also. That means BMW can access that method. B1.break. What do you think? See, B1.break method. Yes, break feature you can access. Here also, A1.break feature we can access. And the car also, a car can access what? Again, let me design P1 dot or C1 dot break feature. Got the concept? What is happening? Are you clear, everybody? So run the code and see the result. So actual break feature is coming from which class? Vehicle class. But still you guys are able to follow here? Yes or no? Because of only and only inheritance. This is the relation, guys, that you need to understand. Got the concept, everybody?
Yes.
What is inheritance? How many different types are there? And the most important scenarios, valid scenarios. I have already added these points in the PPT. The major purpose of inheritance is reusability. So you don't need to write a code again and again. Understand the concept. If the feature is already implemented by some other class, you can directly call it. But how we can call it? There should be a relation. And always remember, inheritance, with the help of inheritance, you can achieve is a relation. What type of relation it is? It is a relation. And here I have already maintained these scenarios. So just focus and prepare well. Is this clear?
Yes.
Okay. So that's all for the day. Let me stop the session. You guys are having any query, you can discuss. Thank you, everyone.